Now we're recording. Okay, let's talk about this book for just a minute. The people that make this book also make your geometry book, which is next year, your Algebra 2 book, which is the year after that, and your pre-calculus book, which is the year after that. And it follows kind of the same pattern. And it's a good pattern. I've used other books that aren't nearly as helpful as this one is. There's a lot of words that are highlighted for your attention. If it's highlighted, you need to pay attention to it. There are examples. Example 1. Now the first statement or sentence in example 1 tells you what task it is that they're going to ask you to do. When you begin your exercises, the first exercise is probably going to have this same task. And out to the side it will say example 1. So if we flip over here, it doesn't say it this time, but it will when we get into chapter 1. Name the set or sets of numbers to which each real number belongs. Okay, I'll go back here to example 1. Name the set or sets of numbers to which each real number belongs. If we go to example 2. Graph each set of numbers on a number line. Then order the numbers from least to greatest. So we look at the exercises. Graph each set of numbers on a number line. Then order the numbers from least to greatest. Mind blown. All right, starting out here. It will not always be like this, but I want you to get started on the right foot. So we're going to read through this. We're going to find out what this section is all about. It says a number line can be used to show the sets of natural numbers, whole numbers, integers, and rational numbers. Values greater than 0 or positive numbers are listed to the right of 0, and values less than 0 or negative numbers are listed to the left of 0. Natural numbers 1, 2, 3. Whole numbers 0, 1, 2, 3. What's the difference between a whole number and a natural number? Anybody? Bailey?
A whole number is every number. Natural numbers are just counting numbers.
Okay. I like that. Anybody else?
I don't remember anything. So.
Okay. Well, it's good that we're going over it. Natural numbers and whole numbers are exactly the same thing, except whole numbers include 0. If 0 is included, then that means it's whole numbers. If 0 is not included, you can't hold up, I guess you can hold up 0 fingers, but you can't count 0 fingers. Your fingers? Whole numbers. Natural numbers. If 0 gets put in the mix, it becomes whole numbers. Integers. What do these 3 dots right here mean? And then you're just going to start over here before we get to negative 3. And there are more after positive 3. Then continue on afterwards. Well, what's the difference between integers and whole numbers? Integers include the negatives. So let's see, I'm thinking of a number 7. What set or sets would the number 7 belong to? What we have just read?
Whole.
Be a whole number, be an integer, and it will also be a natural. Rational numbers. Numbers that can be expressed in the form A over B, or a fraction. Where A and B are integers, they can be positive or negative whole numbers. But B cannot equal 0. Can somebody give me an example of a rational number? Gabe? Can you give me an example of a rational number? Close?
Maybe like 1/5, something like that.
1 over 5? Yeah. Somebody else want to take a shot? Connor?
1/2.
1 over 2? Yeah. What?
1/4. 1/4.
1/4? Mm-hmm. So you just pick, yes, Taylor?
The decimal.
Some decimals, yes. How about, well, let's just go back to our number 7. Is that a rational number? Prove it.
7 over 1.
Way up there. Yes! Woo! Woo! Alyssa, I asked, is 7 a rational number? She didn't just say, yeah. She said, well, yeah. I said, good. And she said, it's the same as 7 over 1. It's any number that can be written as A. A just stands for a whole number on the top. And B. B just stands for a whole number on the bottom. An integer. Either one could be positive or negative, but they are not decimals. Whole numbers. Excellent. Except B cannot equal 0. We'll talk about that in a minute. A square root is one of 2 equal factors of a number. For example, 1 square root of 64, written as square root 64, is 8. Since 8 times 8, or 8 squared, is 64. I love square roots. Do you know another name for square root? Kind of like ninth grade. It's called a radical. Radical. This symbol here that we call the square root symbol, it's actually called a radical. Square root 64. The non-negative square root of a number is the principal square root. We won't need to remember that. Another square root of 64 is negative 8. Since negative 8 times negative 8, or negative 8 squared, is also 64. We're going to learn something about our calculator here. So pick your calculator up, turn it on. Corey. Okay, on the very bottom, right below the 3, that's the negative sign. I want you to type in negative 8 times negative 8. What did you do?
64.
Positive or negative?
Positive.
Positive 64. Because a negative times a negative is
Positive.
a positive. Okay, don't forget that. All right, now, here's what I want you to do. I want you to type in negative 8 squared. The square, we have a button for it. It's right here. The X, put the square on it. So negative 8, and you push that button, it puts the square up there. Negative 64. Hold on. Did everybody get negative 64? I'm bringing this up for a reason. The calculator is thinking differently than you are. When you do negative 8 squared, like we just did, in your mind, it's negative 8 times negative 8. In the calculator's mind, it reads that negative sign as times negative 1. Times, multiply. So now, there's two operations that the calculator is going to do. It's got this times negative 1, and it's also got the power of 2. Which one is it going to do first? Which one comes first in PEMDAS? Power. The exponent. Exponent comes before multiplying. So it's going to do 8 times 8, and then it's going to multiply it times negative 1. Now don't ask me why it's set up that way. I didn't make these calculators. I didn't do that. But you need to be aware of that. The way to get around that is, what was it, Connor?
Parentheses.
Parentheses. It says negative 64. But if I put it in parentheses with the square on the outside, now I'm forcing it to do that times negative 1 first. Get that answer. So negative 1 times 8 is negative 8. And now do the square. Negative 8 times negative 8. Ooh. That was ugly. Positive 64. Now, this is an issue we're going to have all year long. And we just need to get used to, if I'm squaring a negative number, I need to put it in parentheses with the square on the outside. Okay. I see I'm losing you, so we'll go on. What's this called?
Numbers.
No, the whole representation.
No, it's that's a diagram.
Uh-huh.
Number diagram.
It is a diagram for numbers. Venn diagram. It's a Venn diagram. What's this Venn diagram telling us about whole numbers? That bubble for whole numbers, the light blue, it's on the inside of the bubble for integers. So the whole numbers belong to the integers. All the whole numbers are inside the bubble for integers. The integers, that purple bubble, is inside the big square for rational numbers. So any whole number is also an integer. It's also a rational number. So where would 0 belong?
On the phone number.
Whole number, integer, rational number. What about 3?
Natural, whole, integer, and rational.
It's a natural, a whole, an integer, and a rational number. What about 6 over 13?
Irrational.
Rational. It's not an integer because when you do 6 divided by 13, you get a decimal. So it's not a whole number. So it can't be integer. It can only be rational number. All right. Next page. Putting numbers in their proper order. I think there were some questions like this on the little pre-assessment that you took. They gave you like 2 whole numbers, 2 fractions, some were positive, some were negative, and they asked you to put them in the correct order from least to greatest. A number line is good for that. You plot each of those, and then you start at the left, and you write them down going to the right. And you have them all in the correct order. Graph each set of numbers on a number line, then order the numbers from least to greatest. All right, 5 over 3. That's right here. Let's see. 3 will go into 5 one time. Will 3 go into 5 2 times? No. So 5 over 3 is going to be somewhere between 1 and 2. And that's where they placed it right here. Negative 4 over 3. Okay, 3 will go into 4 one time, but 3 won't go into 4 twice. So on the negative side, we're going to go past 1, past negative 1, but not quite to negative 2. So there's negative 4 over 3. 2 over 3. Will 3 go into 2 at least once? No. So it's going to be before the number 1. Is 2 over 3 bigger than 1 over 3? Yes. Okay. So that's why the 1 over 3 comes before the 2 over 3 right there. Negative 1 over 3. 3 will not go into 1 at least once. And so this number also is going to come before the negative 1. And here it is. Now they're all plotted. Now you start over here at the left. The smallest number from this set is negative 4 over 3. Corey, I need you to pay attention. So you write that down. The next one you come to is negative 1 over 3. Write it down. Then positive 2 over 3 and positive 5 over 3. This is a way that a number line will help us get the numbers in the proper order. Woo! Woo, doggy! Express each number as a decimal, then order the decimals. Okay, so let's see here. How would we do 6 4/5? First, turn your calculator on. We're fortunate to have these calculators because we can type it into the calculator exactly the way that it looks. Does anybody remember how you do that?
6 times 5.
Okay, I like that. But if I want to type it in as 6 and 4 over 5, 6 4/5, does anybody know of a way that we could do that in the calculator? I'm not going to disagree with that, but that doesn't put it on the screen exactly the way that it looks.
6
right here.
Oh, once you go to 1,
You don't add the 6.
Then the 6 left 5 should take math and add 6.
Okay? Right. So that simplifies it for us. But we just want to type it in exactly the way that it looks. Okay, here's how you do this. You've probably done this before, but not for a mixed number. You're going to push the alpha button, that's the green one, and the y equal button, which is right here. So alpha, y equal. Now, option number 1 in this list that came up is just for normal fraction. Option number 2, where it says u and then n/d, that's for a mixed number. So just push the number 2. Push the number 2 and fill in the blanks. 6, 4, 5. Okay, now that did the multiplication like you were talking about, and we end up with 24 over 5. We need it as a decimal. So now it's just 24 divided by 5, answer 4.8. So how do you type in a mixed number?
You said 24 divided by 5? Shouldn't it be 34?
Is it 34? I'm sorry, I didn't have my glasses on.
It should be a point.
I'm sorry.
Picky. 6.8. So, again, my question is, how do you type in a mixed number? Tell me how.
Who's your number?
No.
Alpha y equals 2.
Alpha y equals, and then select number 2. Okay, if you just want a fraction, it's alpha y equals, enter. And now it'll let you put in a fraction, just a normal fraction. You can change between the two. Let's look at that menu. Number 1 lets you put in a fraction. Number 2 lets you put in a mixed number. Number 3 changes from a fraction to a mixed number. And number 4 changes from a fraction to a decimal. So we had 20, was it 36 over 5? Is that what it was? 34 over 5? Okay. So here's my fraction, 34, and on the bottom, 5. I'm going to go back, and I'm going to change that to decimal by choosing number 4. Really, that one is just easier to type in 34 divided by 5, enter. Now to take a number and change it to a fraction, I go up here and I highlight the number that I want to change to a fraction. Are you with me, Bailey? I push enter. Now that's going to let me use it. And I push math, enter, enter. And it changed that number to a fraction for me. We'll get a lot of practice with math, enter, enter. Okay. All right, I'm about to lose you, so let's just get on with the work. Here's what I want you to do. I want you to do the even numbers 2 through 18. 2 through 18. The even numbers. Mm-hmm. 2 through 18. Name the set or sets of numbers. So there might just be one answer, there could be as many as 4 answers. And then on number 14, 16, and 18, graph each set of numbers on a number line. Then order the numbers from least to greatest.
How do you want your header?
Right.
How do you want your header?
How do you want your header of the paper? Is there
Oh,
any
that's up to you.
preference?
You can just write page P10